Hi, I'm Pejman, and I'd like to show you how Weasel works. Weasel started as a side project when I was working as a software engineer at a medical imaging software company. I remember I was part of this project to replace one of the most critical components of our product that was nearly 500,000 lines of code with a whole new component. And we do this in a way that this whole effort would not change the behavior of our software for our customers. So to me, this is a very exciting problem. Like, how do we make sure as an engineering team that our daily code changes do not have any unintended side effects? And it turns out many companies deal with the same problem. And of course, there are many existing solutions for it. A well-known software testing practice is regression testing. So with regression testing, we take a software workflow and we run it with different inputs, and then we try to record the behavior of our workflow for each input. For the next version of our code, we do the same for the same inputs, but then this time we compare the captured test results with the previously recorded test results. So that's regression testing in general, but most tools usually store these test results in a bunch of files, one for each test case. Now, these are called snapshot files, and we run the test for a given version. We end up with a bunch of files. We store them somewhere, and then the next time we have a new version, we have a bunch of new files, and then we compare those two sets and see if there are differences. Now, this works for small projects, but it quickly breaks down and becomes frustrating as the number of our test cases or the size of our test results grow. So it doesn't work that well at a scale. And we need that at a scale when testing mission-critical software in industries like autonomous driving, finance, or robotics. So Weasel offers continuous regression testing without using snapshot files. Instead of writing our test results into files, we use the Weasel client libraries to submit our data of interest to the Weasel platform and let the platform do all the legwork for us. And take charge of storing and retaining results or comparing against our baseline version. This saves a ton of time for engineering teams and helps them build and maintain software more efficiently. So with that long intro, let's see Weasel in action. Now, what you see here on the screen is a cloud version of Weasel at getweasel.com. Of course, the platform can be deployed on-premise as well. What I've done is I've created an account. I've created a team called Tutorial. And then in that team, I've created a suite for my workflow under test. Now, the workflow under test in this example is actually an examples repository in the GetWeasel GitHub organization. So here, I've basically submitted some files. That repository has a GitHub Actions workflow that every time you create a pull request, it runs it builds the code and then runs the regression test. So these results have come up here. Let's open up one of these versions. You see that I'm testing the workflow with three test cases, three inputs. Now, for each input, I'm basically running the test, and in running the test, I am capturing value of data of interest, like maybe important variables or return values of some functions that mean something, and I want them to stay the same between different versions of my code. So in this case, if you're capturing keys and values, you see that these variables can have any type. In fact, the client libraries preserve the data type when capturing test results, and then submits the test results in their original data type so that the platform can compare the test results in their original type. So in this case, a birth date, which is a custom user-defined type, is shown as an object. And if I expand this, I see that the fields and member variables of that class as a JSON representation. In addition to data about the behavior of my workflow, Weasel enables us to capture data about the performance of our workflow. So in this case, there's a separate tab, metrics, that shows the execution runtime of different pieces of my code. Like in this case, these are functions that I'm interested in, and I want them to run more or less basically the same. So if I go back to the demo, I can actually click on this new version, which has some differences, and immediately the platform tells us that it has compared the version against the baseline version, which was that first version. And now results of those comparisons are shown here. So I can click on this particular test case, and I see that now the height has changed. So it used to be 6, and now it's 6.1. Now, because this was a floating point value, it's shown as 60999. There are times when we inspect the results and you're actually happy with the changes. Like maybe we wanted to intentionally make changes to the behavior of our code. In that case, then we can actually promote this version and then let our other members of our team know why we are promoting this as the new baseline. This way, if a new version is submitted, it would be automatically compared against the new baseline. We can, of course, compare any version against any other version using this navigation bar here. And there is a lot more to Weasel, but I don't want to spoil the fun. If you like to learn more, feel free to create an account at getweasel.com and check out Weasel for yourself. And of course, I love to hear what you think. Thanks for watching this video.